If you have a real estate company, you might wonder how much commission fees you can get in the future. But of course, if the housing price decrease with time, it can become a problem for the sustainability of your business and the ones of your competitors. In this video, you will see what can explain the real housing prices of Italy that shares a demographical outlook similar to many Western countries. And you understand that we can use the same statistical approach that uses demography also for other kind of KPIs, not just related to companies, so turnover, but also to organizations. I collected the data that goes from 1947 to 2023. This is our target variable that comes from the Fred website that I sometimes use in my videos because they have a lot of accessible data. And here we have our target variable. And you see that after 2008, that corresponds to the Great Recession, Italy experienced an important decrease for the prices of residential properties. And except you live in a major Italian city, it means you can have less commissions from the sales of such kind of property. So the statistical analysis involves what explains this downturn and possibly this positive trend. I collected, of course, the data on the population because, as you know from economics, supply and demand can influence the price. That means if a population grows too much pressure on a limited stock of houses, and if the population decreases, and of course the prices go down. Then a natural balance is another demographical variable. That means the difference between the newborns and the deaths, and as you can see, in the last decades it became negative. That is not something just related to Italy. Then I collected the total fertility rate, that is the average number of kids that a woman has, and as you can see we start almost from 3 and we end to this value that is a tragedy in demographical terms, because we need a value of this kind in order to have a stable population, otherwise you have one in decline. As a random fact about me, I was born in the year that Italy had the lowest total fertility rate since it unified in 1861. You might wonder, how did it decrease afterwards? Because of the immigration rate. As you can see, from here on, Italy belonged to the countries that had an outflow of people, and after the oil crisis it became the opposite, also because in Europe they changed the laws. I want to underline again that this statistical analysis has a demographical approach, and I want to underline this again because at the end of this video you will see another kind of approach that I didn't do. If we move to R, the statistical coding language, to perform the analysis on this data in order to explain our target variable, we start immediately from this control that I understand that says you nothing, but it is a very important control that says our target variable explains itself. So it is autocorrelated. What does it mean? That if you want to use a model, we have to take this into account. So the price at this year, here it is in quarters, but never mind, it is explained also by the same price, but one period before, 2 periods before, and so on, even 14 years before. So we have to take this into account. So we can't use a basic model like a linear regression to do so, but you'll see more going on in the video. Then the second control, very important, is to check the distribution of our target variable, because in a simple model like a linear regression we need a normal distribution, and this is not a normal distribution. It is something much more weird. So we have already 2 hints that say that our model will have a flow if we start with a basic one like a linear regression. You see that if we transform the target variable with a logarithmic transformation, it becomes a bimodal distribution, so something we can handle more with a basic model. Let's do the correlation. This is our target variable, and you see very high correlations, and I generally say that when we are above 0.85 we have collinearity. You see that the lowest and probably the most useful is the migration rate, but it is not enough because then I did partial correlations, that is the correlation cleaned by the effects of the other variables, so it is more rigorous. Otherwise we end up with correlating the number of movies of Nicolas Cage and the number of cases of autism. And you see very different correlations than the one you observe here. For example, instead of 0.86 for population, we have less than half. But we don't have to look just at the absolute number of correlation, but the significativity that tells us where we have signal and where we have noise. And where we have noise, it means we won't use those variables in the model to explain the real housing prices in Italy. It is a bit hard to read, but we want values below 0.05, and here we have scientific notation, so as significant we have this, this, and this. Let's start with a very basic model that uses the population and the migration rate, and you see that we explain almost 80% of our target variable. And in this model you see that we could already answer to the question of this video if we wanted to do a not serious statistical analysis, but we see that this coefficient is much higher than this one, and it means that the migration rate really helps with this model to increase the real housing prices. Let's do a model with the interaction between the population and the fertility rate. We explain 84%, and that is an improvement, and you see that again migration rate has a higher coefficient than population. Again, this is another hint on our final answer. But if we do the diagnostic, because it is not enough to have this number, we see something. This is problematic, because in the dotted part you see when it actually means a green light. Next model, we take the log of our target variable, because as you saw from this chart, it becomes more handleable for this kind of model. You see that again we explain almost 84%, but we expect less problematic diagnostic plots. This one surely not, this one improved a bit, and also this one. This was the one before, and this one is the new one. But since we saw autocorrelation on the target variable, we have also to see the autocorrelations with the other variables. And you see that many variables, and this is our row for the target variable, many variables have a high significativity for this control. Again, if we have something off the model, we know why. If we try to do the model that uses the total fertility rate 1 year before, we see that we almost reach 90%, but since you don't have just to look at this, if we do the diagnostic plots, you see that this gets worse, this doesn't really improve, and this, one of the utility of checking the diagnostic model is that sometimes they highlight possible outliers, and they can decrease the performance of the model. So let's take out those observations that you can see inside those charts. If we do it, again 90% of performance, let's do the diagnostic chart, and now we have something decent, even if this one is improvable. Let's do another model again with the log of the population, and you see that things get worse again, even if we remove that line of data. Now let's do the same of this, but with the log as transformation of the target variable. We go beyond 90% because we removed those problematic observations, but if we do the diagnostic plot, we see the same problem basically here. And mind that when we put log for our target variable, also the interpretation of all this changes. For this last model, if we do a check that is an extra of the ones you see here, and it is if we have autocorrelations on the residuals, the answer is yes, and this is a problem, because it means we can't use such kind of model, but time series model. But let's say that if we put a lagged variable, we could resolve this. Also, if we take out some rows of our data. And the answer is no, because here you see that you explain 100%, and that is a red flag in statistics. So let's take that model as the final one. Let's see it again. And this one doesn't have the transformation on the target variable. Again, almost 90%, and we have a problem here. And sometimes it is a compromise you have to do with your analysis. You can't have a perfect model, and you compromise on the kind of error you have. Some kind of errors are worse than others. One of the problems is having heteroskedasticity, a terrible word, that basically says that the significativity and also the estimate in our model are distorted because of the presence of that non-constant variance, that is the English word for that Greek word. And since we have it, because I did the test, we have to fix all this. And in order to have a reliable summary, inferentially speaking, that means that deals with the significativity, we have to use such technical commands. Let's print this other summary again, and you see that, for example, for the intercept we have the sig coefficient, but let's go to see our hot variable, that is the migration rate. And you see that is the same. Here we got lucky because we have the same inference on the model, so we can have the same conclusion we have on the, let's say, distorted model. But what does it say? It says that population has a low impact on the real housing price because it is a 10 to the minus 6. Instead, the migration rate is a 3.7, so it is way higher. But there is a variable that has more weight to explain the phenomena with this model. I want to underline it, and that is the TFT, that is almost 60 times more. Objection: the TFT, that is the total fertility rate, is mostly driven by immigrants, so we have to take this into account. It is true that we can find data of the TFT for locals and for immigrants, but we can't find it starting from this date. We can't find it after this year, more or less. This is one limit of this demographical approach. But again, the answer is yes, but there is something more important with this model that drives more the real housing prices. If immigrants that have the highest total fertility rate stops to do kids, it becomes a problem. And we already know this happens because the second generation, especially in Italy, but not only, have already this problem. So this is the conclusion, again, with this model that also has an interaction that is more difficult to explain, but you see that it is negative and it has the same order of magnitude of population. Now, let's go to see another approach that is macroeconomical, because as I said, what I did has a demographical approach. We see that Agenzia delle Entrate, that is the IRS of Italy, did a similar study in terms of aims, but first using this data range, so it is much less than what I did, and then they used just 18 Italian cities, second difference. Third difference, they used macroeconomic variables. They just used this as a demographical variable. They used a VAR model, that is a time series model, so a closer fit to the actual data behavior we have. And the VAR model is also used in monetary policies, something that I discussed in other occasions. But anyway, let's go to see the results. And here are the results. They explain 81% with those variables in those years for those cities. And as you can understand, this model has less performance than what I did. This is the test for checking the autocorrelations on the residuals. As a conclusion, I want to show you a broader academic research that comes from the Banca d'Italia. So it's something, let's say, higher than the IRS of Italy, and they used much more data than the Agenzia delle Entrate. Let's go to see the charts because I found them very useful. And here you see that Italy has a more negative outlook because other 14 countries have a less pronounced downturn, also because they have more migratory attraction. Here you see the strong relationship between the deviation of the house prices and the land prices. And here you see what I mentioned at the beginning of the video. That means, as everywhere else in the world, major cities, that is principali città, has a different behavior than the whole country. That means major cities are more expensive. That's it. That's all for this video, and as a owner of a real estate company, you might wonder if this is the outlook, what can Italy do to improve the inflow of immigrants? And that is a completely whole different topics that it is far more complex because it involves also politics. But I will do a video about it in the future. If you feel discouraged by the findings of this statistical analysis and you want to know anyway how to improve the situation of your real estate company, you can contact me on the link you see in the description, and we'll discuss your situation in a free call. Bye and see you the next time.